Hello everyone, I am Dr. Jyoti Mandala. Welcome you all to the video lecture series on the course Operating Systems. From this lecture onwards, let us start learning about what are all the different kinds of CPU scheduling algorithms. Uh, we understood up to in the last lecture what is CPU scheduling, and we also understood what are all the different types of CPU scheduling algorithms are there. We have just listed them, and also we have understood different types of scheduling criteria. What are all the different criteria are there, like what are all the evaluation parameters are there, so that we can find out which is the best CPU scheduling algorithm is. Alright, so with that basic information, let us understand first scheduling algorithm, which is a non-preemptive scheduling algorithm, FCFS. Now what is this FCFS? FCFS stands for first come first serve. Just note down all of you, FCFS stands for first come first serve. As the name suggests, first come first serve means we already understood in the last lecture what is the use of this CPU scheduling. CPU scheduling is used to choose one process from the ready queue and it can be sent to the running state. Now, if you are adopting this FCFS CPU scheduling algorithm, then the first process that has come to the ready queue, that only will get a chance to be sending to the running state. As simple as that. Now, what kind of scheduling algorithm is this? This is non-preemptive scheduling algorithm. So just make a note of this point. This is very important. Non-preemptive is nothing but once it has been sent to the ready queue, until and unless the process finish its execution, it cannot release the CPU. That means the CPU cannot switch to another process. That is called as a non-preemptive scheduling algorithm. So FCFS comes under that category. So to even more understand this one clearly, let us take one example and we will solve that one. Okay, so what I'll do, I'll take one this one. 5 process we'll take one problem and we'll understand that one. Okay, so just note down this problem, all of you. We'll take one example. Now what I will do, I will take 5 process. Okay, so let me take, I'll show that, so that this is the problem. Now we will represent in the form of table, then it will be very much easy for us to understand. So the first column, let us consider, represents the process what we are using. Okay, and the second column, let us consider, represents the arrival time, and the third column represents your amount of time required to finish its execution. Okay, just note down the first one. I'll just write it here. What I'll write, this is the process name. PN is nothing but process name, and this is your arrival time, and this is your CPU time required, amount of time required to finish its execution by each process. That is called as burst time. Burst time is nothing but the amount of time required to finish its execution. So let us consider 5 process P0. So P0, let us consider this is the problem. This you will be given in your exams. The question will be given in the form of this one, where what is the process, how many process, what is the arrival time of each process, and what is the burst time of each process. That information will be provided to you, and you need to use this FCFS algorithm, and you need to find out what is the waiting time and what is the turnaround time. Okay, so let me first write down the question. P1 requires, arrival time is 2 and this one is 6. P2 is 4. Okay, and then P3 is, let us consider 6 and 5. 6 is the arrival time, and 5 seconds, let us consider the time is in seconds. 5 seconds of burst time is required. And P4 whose arrival time is 8, and this one is 2. Right. Now this is the question. You will be given a question like, consider the following number of process whose arrival time is and burst time is mentioned as below. You calculate the waiting time and turnaround time using first come first serve algorithm. Now how to solve this problem? So to solve this problem, generally what is the scenario we will be using is, we need to maintain one queue called ready queue. Okay, so just I will write that one. We will maintain, okay, what are all the parameters we are going to maintain? Ready queue. And also we need to draw one Gantt chart. What is the use of that Gantt chart is, Gantt chart represents the time interval when it has started the execution, the complete information, like when it has entered into the ready queue, like when the CPU time, utilized time, will be maintained in the form of a Gantt chart. Okay, so I will tell you how to draw this one. Okay, and finally we are going to find out the average waiting time and the average turnaround time. That is also how to find out, that we will see. But first what we'll do, we'll find out what is this ready queue and what is this Gantt chart. First we'll understand this one. Okay, ready queue is nothing but we will have one queue like this. So what we'll do, let us maintain one queue like this. Because I'm saying it queue, don't think like this algorithm may work like that, but for other algorithms also we will be using the same terminology. Ready queue is nothing but first in first out, but that may not be the case with the other algorithms. For this algorithm it is apt. Okay, so okay, now let us understand how this first come first serve algorithm. Now whenever the problem is given to you, we need to always check the arrival time. Arrival time means at 0th second any process is coming. Yes, this process is coming. So what we need to do, we need to take this process and it has been arrived means it has to be added into our ready queue. Now whenever it is added into the ready queue, it can be taken because this is the only process available in the ready queue now. Okay, I think you all are recollecting that one, ready queue. This means ready state, and this one is our running state, right? Now this is our ready queue, the only process available. So from here you need to send one process to the running state. So we are using here FCFS algorithm, right? Now P0 has been selected. Now this Gantt chart represents the timeline. So how it is representing, I'll tell you. So 0th second, 1 second, 2 seconds, like that we need to have a timeline. Let me draw it very clearly first so that it looks good. Okay, this is the line, and always remember Gantt chart represents the timeline. Okay, okay, now what I will do, at 0th second we got our process. Okay, now the process started its execution, P0 started its execution. How much time it requires? It requires 3 seconds. So because it is first come first serve, that this has arrived first and it will only get the chance. So it will be executed for 1 second. Now after executing for 1 second, we need to check the arrival time. Any process is coming at 1 second? No process is coming. And we can continue, P0 continues its execution 2 seconds. Any process is coming? Yes, at 2 seconds P1 is coming. So we need to add P1 to our ready queue. That means P1 is now available in the ready queue. Now P0 should continue. Why? Because P0 requires 3 seconds of time. One more second it will execute and it will stop executing. So this is the end of this P0. At 3rd second any process is arriving? No, nothing is arriving. We can stop executing. Now check the ready queue. Any process is waiting for its process, for its time? Yes. P1 is only process available. Now we need to choose this P1 and P1 got its time. Okay, because if any other process is also there, then we need to see which one is entered into the ready queue. Obviously the first one is there in the ready queue, that only will be in the order. As of now that scenario has not come. So P1, now P1 will be executing. How much time P1 requires? 6 seconds it requires. So 1 second it has been executed. At 4th second you can see P2 has come. So P2 should be added to the ready queue. Okay, and then 1 more second it will be executed. Understand, 6 seconds is required, only 2 seconds we have executed. 5th second no process is arriving, we will execute 6th second. 6th second any process is coming? Yes, P3 is coming, add that one to the ready queue. Okay, so 1, 2, 3, 7th second, 7th second any process is arriving, no process is arriving. Okay, then 1, 2, 3, 1 second, 2 seconds, 3 seconds, 4 seconds, and then 5th second. See here 6 seconds are required, right? Now 8th second process P4 has arrived. P4 has to be added into the ready queue, and 1, 2, 3, 4, 5, one more second is required. Now here comes the P2 end. P1 has been end. Okay, so understand 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds, 6 seconds. 6 seconds of CPU time is required. Understand, because this is for non-preemptive scheduling algorithm, it has to complete its execution. Then only CPU will switch to another process. Now we have with three processes P2, P3, P4. Which process has to be selected? We are using FCFS, first come first serve. So among these three, P2 has arrived first, so that has to be selected and it has to be sent to the ready queue. Right, now P2 requires how many seconds? 4 seconds. Right, so after this 8 seconds, no other seconds are there, so no need to check the arrival time. Just execute this one for 4 seconds. So 9, 10, 11, 12, 13. So 1, 2, 3, 4. So P2 is completed its execution. Right, now I will just extend these lines and then this one. Okay, now you can see P2 has completed. Now we have two processes. P3 has come first, so P3 only will get the chance to execute. How many seconds required by P3? 5 seconds. So 13 plus 5, 18 seconds. I am not checking. Why? Because I am not checking the other process, because after this no processes are there. So just continue its execution. Okay, 13 plus 5. Next P4 is the only process available in our ready queue. So P4 will get a chance, which requires 2 seconds. So 18 plus 2 is 20. So this is your Gantt chart. So Gantt chart talks about the CPU time utilized by each process. Okay, so by seeing this Gantt chart only, we will be finding out what is the waiting time of each process and what is the completion time of each process. So now what I'll do, I'll take one more column for the waiting time and one more column for the completion time. For each process, let us calculate. We will fill in this table only. Okay, so in the last class we already learned about the formula for the waiting time and turnaround time. Do you remember that one? Okay, so waiting time and turnaround time. If you want, I'll write on the formula here. Waiting time is equals to start time minus arrival time, and turnaround time is equal to completion time minus arrival time. Okay, now let us fill this waiting time here. Okay, now what is the waiting time for P0? I will write here so that it will be clear to you. Waiting time, we are talking about waiting time. Okay, P0, what is the start time for P0? P0 started at, from the Gantt chart, it started at 0 seconds minus, and what is the arrival time of P0? You can get it from this table, 0. So 0 minus 0 is 0, right? P1, what is the start time from P1? P1 start time is at 3 seconds, right? So we will write that 3 minus, okay, its arrival time is 2 seconds, so 2. What is that? 1. Now P2 start time is 9 seconds, right? So 9 minus, what is the arrival time? 4. 9 minus 4, which is equal to 5. So similar fashion you can write P3, what is the start time? 13. 13 minus 6, 7. And P4, what is the start time? 18. 18 minus 8, 10. This is how waiting time has been calculated for each process. Now let us see turnaround time. Turnaround time, what is the formula? I will write here. Turnaround time. For P0, what is the turnaround time? You should see the completion time. What is the completion for P0? 3 seconds. So 3 minus arrival time is 0. 3 minus 0 is 3. Are you all understanding? Now, what is that for P1? What is the completion time for P1? 9 seconds. So 9 minus what is the arrival time? 2. Now which is equals to 7. Right? Now for P2, 13 is the completion time minus arrival time is 4, which is nothing but 9. Similar fashion you can see for P3, 18 minus 6, which is equals to 12, and P4, 20, sorry, okay, P4, what we are getting? P4 is nothing but 20 minus 8. What is that? 10. Okay. One second. So I'll write here 10. Okay, so this is about the waiting time and turnaround time of each process. Sorry, I think 20 minus 18 is 12. Okay, now this is how the waiting time and turnaround time of each process can be calculated by using these two formulas. Okay, now sometimes you may be asked to calculate the average waiting time and average turnaround time. How you will calculate the average waiting time? The total of these values by total of these number of count. So can you tell me what is this average waiting time? I'll just check whether my leave it. So waiting time is equal to average is equal to, can you get me the value here? How you will get the value? So 1 plus 5, 6 plus 7 plus 10. So the total value will be your 23. 23 by 5 is equal to 46.4.6. Okay. So you will get a value of here. Average waiting time value is 4.6. Right? Now what is the average waiting time of this one? Average turnaround time, can you calculate meanwhile all of you? Average waiting time. So average waiting time is equal to 4.6. How you got this one? By adding all these values by total number of process. Okay. Can you calculate average turnaround time? Average turnaround time is equals to how much? 3 plus 7 plus 9 plus 12 plus 12, which is equals to 43. 43 by 5 is equal to 8.6. So you just understand here how this algorithm is working. The algorithm is working, the working of this algorithm is very simple. You need to consider the process that has been arrived into the ready queue first, that has to be selected first, and that has to be assigned to the CPU. So this Gantt chart will represent that one. Okay, so this is about the FCFS algorithm, which is a non-preemptive scheduling algorithm. Remember one point, the waiting time and turnaround time formulas are same. So we will be adopting the same formula for all the algorithms and we will be understanding how it will work. Now there is a problem with this FCFS algorithm. What is the problem is, let us consider another example. Sometimes what happens, no, if the arrival time is not given, okay, if the arrival time is not given, then in that case we will consider all process has been arrived at the same time. So let us take one small problem and we'll understand what is the problem. What is the problem with this first come first serve algorithm. Okay, so to make you understand what I'll do, I'll take one example. The problem, let us consider three processes only. Okay, so process P0, P1, P2. Okay, observe here, there is no arrival time will be given. Okay, so this is P0. Okay, so this is P0 and P0 requires burst time of 24 seconds and P1 requires 3 seconds and P2 requires 3 seconds. Alright, now there is no arrival time given. If in this case, if no arrival time is given, then we will consider the arrival time is same for all and all has been arrived into the ready queue. Now we don't have an option of choosing which one has, we don't know like which one has come first. Now it depends upon the user's brain, or else suppose if you have selected the option of P not arrived first, in that case, so P not arrived first and then P1 and then P2. Let us consider our ready queue is like this. Okay, now P0 will get the chance first, so P0 will be executed and it will take 24 seconds and then P1 will be executed which will take P1 will be executed which will take 20 seconds of time because 3 seconds are required and then P2 30 seconds. Now if you use this one, what will be the average waiting time? The waiting time will be taken as, this one is 0 and this waiting time is 24 and this waiting time is all 27. Isn't it or not? So the average waiting time we will get is 17 seconds. Now suppose if we choose the another order, here we have chosen the order of P0, P1, P2. Let us consider another order where P1 has been selected first and then P2 is entered into the ready queue and then P0. Let us consider this order. If you are choosing this order, then P1 will get a chance, ready queue, which will be executed for 3 seconds, P2 will be executed for 3 more seconds, 6, and then P0 which requires 24 seconds, that is 30 seconds final. Now if you are selecting this option, in that case what happens? Let us consider this case, waiting time, where we have selected P1, P2, P0 order, right? In that case, what will be the waiting time of this one? 6 seconds, isn't it? What I have done, P0 has started at 6 seconds, okay, right? And then this one is 0 and this one is 3. So the average waiting time is 3. Did you see there is a drastic change in between these two? There is a lot of difference. If you are choosing this one, 17 seconds is the average waiting time. If you are choosing this one, this is very less. Now this problem of not choosing the correct order, if you choose this order, it is very well because we are getting 3 seconds of average waiting time. But if because there is no proper arrival time given here, we are considering all has arrived first and we are choosing of an order of this one, suppose in that case we are getting a more waiting time. So this problem, this way of taking like may not be generating the correct or we can say in the other words like generating more waiting time by choosing a wrong order of execution is called as Conway effect. Note down all of you, that is called as Conway effect. And FCFS suffers from this Conway effect. That is what we have understood now. Just now we have seen this FCFS suffers from this Conway effect. So to solve this problem, they have come up with a different type of algorithms, that is the other types of algorithm like SJF, priority, round robin. All these algorithms we are going to understand. Those algorithms are not suffering from this Conway effect. Only FCFS is suffering from the Conway effect only when the arrival time is not given. Okay, so to solve this problem, we will be understanding the different algorithms in our next lecture onwards. Alright, so I hope you all are clear with this today's lecture. So in today's lecture we learned about this FCFS algorithm in detail, how it can be solved, and what are all the parameters of waiting time and turnaround time can be calculated, and what is the disadvantage of this FCFS, that is Conway effect. Okay, I hope you all are clear with this today's lecture. Let us all meet in the next lecture. Until then, thank you all of you.